In this video, we are going to see the integration of trigonometry function. Before solving the problem, so let us go with some of the trigonometry identity which is already we studied in our math too. So we know that the sine cosec x is nothing but 1 over sine x, and then sec x is the reciprocal of the cosine x, and tan x I can write it this one as sine over cosine, sine over cosine, and cotan x which is equal cosine over sine, or we can write it as cotan as 1 over tan. Both are right. And in addition to this one, we will have some identities. So what are the identities we will have? If you have sine square plus cosine square, sine square x plus cosine square x is equal 1. From this, we can deduce the two formulas. What are they? So we will reduce sine square. I will fix the sine here. So I will move the cosine that side. It becomes 1 minus cosine square. And similarly, I will fix the cosine square here. I move the sine that side. It becomes 1 minus sine square. So this is the first one. Now, the next one, we will have the next identity which is given by sec square minus tan square is equal 1. Similarly, here also by using this identity, I can deduce the two results. What are they? If I fix the sec square here and move the tan square that side, it becomes 1 plus tan square. And the tan square can be written as tan square x can be written as sec square x minus 1. So this is the identity we can deduce from this result. Now the next one, we will have the cosec and cotan. So here the next identity which is cosec square minus cotan square which is equal 1. So from this I can deduce the two formulas. What are they? Cosec square x is equal 1 plus cotan square x. And if I move the cosec square that side, it becomes sec cosec square x minus 1. So these are the, using three identities I can deduce the formulas. So this is what I want to show. And in addition to this one, there is another formula we are using frequently, that is a double angle formula. So that is the double angle formula. What is the double angle formula? So we will have here, this is sine 2x. How will you write sine 2x? This is 2 sine x cosine x. And here cosine 2x is equal cosine square x minus sine square x. So using this result, we will prove the some result here. This is a double angle. We will discuss first double angle. This is what? Tan 2x is equal to tan x over 1 minus tan square x. So this is the double angle formula. So this is all our double angle. Why? It is the angle is 2x. Now we will go through the next one, which is half angle. We have a half angle. We know the formula as sine square. We will use sometime the sine square is equal 1 minus 2 cosine x over 2, and in place of cosine square I will use 1 plus cosine 2x over 2. And what about the tan square? Just divide. So you will have tan square x is equal sine over cosine. This is 1 minus cosine 2x over 1 plus cosine 2x. The 2 get cancelled. So this is the formula we are using. Now, let us go to the problem. The first one, integration of sine, that is integration of cosine square 1 over cosine square dx. So how will you solve this one? So the solution is very easy. I have to make use of the trigonometry identity. What is 1 over sine? 1 over cosine, which is what? Sec square x dx. Since sec square dx, direct formula we will have. That is tan x plus c. So that's it. And similarly here, we will have a sec x, sec theta in the numerator. What about this part? 1 over sine. What is 1 over sine? Which is again a sec theta. So it becomes, the integral becomes sec into sec, which is sec square. So here we have already sec, and the 1 over sine, 1 over cosine, which is the sec theta. So we will have sec square theta d theta. So integration is direct, which is tan x plus c, because it is an indefinite integral. We will write it as a constant c. So it's going to be a same thing, but the different format. If you know the trigonometry identity, you can solve the problem. Here we cannot write it. This is cosec square, because if it is without 1, I can write it as 1 over sine as cosec, but it is 1 plus in the denominator. So here, whenever you will find it like this, you have to multiply the conjugate. So what is the conjugate of this term? The conjugate of this term, 1 minus, if it is plus, I have to multiply minus 1 minus x over 1 minus x into dx. If you have 1 over 1 minus, I will multiply plus. So therefore, what is the simplification? We can do it here. So this in the numerator and denominator. If in the numerator is simple, it is with multiply with the 1, you will get 1 minus sine x. Khalas. Okay, done. What about the denominator? The denominator, you will find it here as what? This is actually a plus b, a minus b. What is the rule you will have? A minus b into a plus b. The formula is a square minus b square. So I will write it as 1 square minus sine square into dx. But what is 1 minus sine square? 1 minus sine square. From the identity, from the above, 1 minus sine square, which is nothing but cosine square x. So I replace this one as cosine square x. Integral 1 minus sine x over, so this is nothing but cosine square x dx. Now how will you integrate this one? Just, there is a single term in the denominator, therefore I will separate this part. What happened here? When you separate this one, 1 over cosine is what? Sec square x minus, we will have here, so I will write it the first one, but then we will differentiate. So here I write it this one as 1 over cosine square x minus sine over cosine square x dx. So how will you write this one? So therefore I can write it this one as this part 1 over cosine, which is nothing but sec square x minus. So how will you write this part? So this is square is there. I write it as sine x over cosine into 1 over cosine. If you multiply, you will get this one. 1 into sine, it is sine x. Cosine into cosine, which is cosine square. Now what about this part? Sine over cosine, which is nothing but tan. What about 1 over cosine, which is sec, into dx. Now what is the integration? So integration of this sec square x is tan x. The integration of sine tan x is sec tan x is sec x plus c. So this is the answer. Here what we are doing here, just we are first multiplying the conjugate and we are applying the a minus b, a plus b rule. This is a square minus b square, again identity. 1 minus sine square is cosine square. Since there is a single term in the denominator, therefore I can separate. I can separate as a 1 over cosine square minus sine over cosine square. 1 over sine square I can write it directly as sec square x, but sine over cosine square I can write it as sine over cosine into 1 over cosine. If you multiply, you will get this term. So therefore, this sine over cosine is tan, 1 over cosine is sec. So integration is direct. So sec tan is nothing but the integration is sec x plus c, since it is an indefinite integral. Now let us go to the next one. Here we will have integration of tan over cosine. How will you write 1 over cosine? How will you write 1 over cosine? 1 over cosine is nothing but sec x. Is it right? So after that, the same thing I write it here. Integral tan x dx. So integration is direct. What is the integration of sec tan? Which is sec x plus c. Then we will have the next formula here. This is the same thing what we have done just before. This is the same concept we are applying in the separate problem. So we will do it here as square term is there. So I will split as cosine x over sine into 1 over sine. So if you separate, so what is this one? What is this one? This is cosine over sine, which is cotan. What about 1 over sine, which is cosec into dx. Now the integration is direct. What is the integration here? We have minus cosec x plus c. So this is the direct formula, direct integration. Now we will have another one. Yes. Here tan square. How will you write it? The tan square value. Tan square. The tan square value. I will write it this one as sine over cosine first. Sine over cosine. Okay. After that, what is after that here? I will make use of the identity. So whenever you will find it the square, sine square, cosine square, I will write it as a identity. What is this one I can replace? Sine square can be replaced by 1 minus cosine square into dx. It is the same story, we will do it again. Since there is a single term in the denominator, therefore I can just separate as a two terms. So what we'll have here, the integral 1 over cosine square x minus cosine square x over cosine square x into dx. So what happened here? I will cancel the entire term here. There is no cancellation. Now, what is the integration here? Simplify first. So the integration is here 1 over cosec, which is sec x minus, here you will find it 1. So this is my formula. Otherwise, there is an alternate method as well. Here we will do it that one as well. So what is the differentiation? Integration of sec square, which is tan x minus x plus c. You can write it this. Otherwise, you can write it here the same rule. Yeah. Otherwise, I can write it this one or direct formula. What is this? Tan square x dx. What is the identity we are using in the tan? In the tan square, what is the identity? Tan square is sec square x minus 1. So this one I will use here. Because of tan square, I will use sec square minus 1 into dx. This is a direct identity. So here it is the same thing at the last you will find it. These steps are same. Now what is the integration? Integration of sec square, which is tan x, integration of 1, which is x, plus c. So final answer is going to be the same in both the method. Clear? Now the next one, I will make use of the same trigonometry identity. So it is 1 plus sine square theta will be same. Here cosine theta. So how will you write this one? Sine square plus cosine square. In the next problem, we will have integral 1 plus sine square t cosec t dt. So how will you write the cosec t? So I will write it this one as 1 over sine t. So thereafter, I just simplify this one. What is the cancel? You have one time get cancelled. So what are the remaining terms? So you will have 1 plus sine t into dt. So direct integration. What is the integration of 1? Is it x? No. Why? Because here the variable is t. Therefore, I have to write it as a t. 1 is t. 1t plus. This is minus. What is the integration of cosine? Sine, which is minus cosine t plus c. So you can simplify this one as t minus cosine t plus c. So this is the final answer. Now we will have the next problem, which is 6-2. So since it is given as a what? Double angle. I will make use of the double angle formula. What is the double angle formula? Integral 1 over 1 plus, since the value is given for this one as what? For this one, cosine 2x. You see in the num up, you have cosine 2x is cosine square minus sine square. So I write it that one here. Cosine square minus sine square. Cosine square minus sine square x into dx. Now I write it in the order. So first I will rearrange the denominator. So I write it 1 minus sine square first. After that it is cosine square. Then we will have here. Now what is this one? 1 minus sine square. Why we are rearranging? Because I need the identity. So 1 minus sine square, which is nothing but cosine square x. So therefore I write it integral 1 over cosine square x plus cosine square x into dx, which can be written as 1 over 2 times of cosine square x dx. 1 over 2 is outside. So 1 over cosine, which is sec square x, upon integration you will find it, which is tan x plus c. This is a direct formula. Integration of sec square, which is tan x plus c. Now here, the last problem we will have here. Here also the double angle, right? Here also we are using the double angle. So I will make use of the same thing. What is this? Over sine square x cosine square x into dx. So I will make use of this one as cosine square x minus sine square x from the above, the double angle formula. Since there is a only single term in the denominator, therefore I can just separate as a two terms. So this I will separate as a two terms. So therefore we will have integral cosine square over sine square x cosine square x minus the next term is sine square x over sine square x cosine square x. into dx. What are the terms which is cancelled here? The cancelled term is cosine square with the cosine square cancel. Here sine square with the sine square with cancel. So we will have here integration of, this is the integral of 1 over sine, which is cosec square x, minus 1 over cosine square, which is sec square x into dx. Since the integration is direct formula, what is the integration of cosec, which is minus cotan x, minus in the integration. So what is the integration of sec, which is tan x, plus c, since it is a indefinite integral. So now the next one we will have tan and cotan. Now in the last problem we will have a tan square, but here it is tan. How will you write tan? How will you write tan? Which is equals to sine over cosine. Sine over cosine. This is dx. Now here we have to use the substitution method. So I will take the u as a denominator. So what happened? The denominator? Denominator is cosine x. What is du? Which is equal minus sine u x dx. Now this one minus I don't want. So you will have sine square x dx. Because the integration is not possible directly, we will go for the u substitution method. Now this integral becomes integral 1 over u, and this one, what is this part? Sine x dx, which is minus du. Now what is the integration of 1 over u? 1 over u is nothing but len x plus c. So if I substitute the values, so you will get len minus len cosine x plus c, or we can use another method, which is if you raise the minus here, it become 1 over cosine. 1 over cosine is len sec x plus c. Both are we can use as an integration of tan x. Now the last problem we will have here, which is a cotan x, which is similar to the tan x. So I will write it this one as integration of cosine over sine x dx. Now here the integration is not possible directly. We have to go with the u substitution method. The substitution method, what is your u value? I will take the denominator so that the dv will be in the numerator. So you will have sine x du, you will find it cosine x dx. Now the given integral is converted into 1 over u, and this part, what is this one? Cosine x dx, which is nothing but du. Now what is the integration now? The integration is len x, len u plus c. After last step, we have to substitute the value of u. So u value is nothing but sine x. So this is the integration of the tan and cotan x. So we have to use the substitution method in order to find the values. So with this topic is completed. If you want the PDF file, you will find it in the description. Thank you.